Akaflieg Köln LS11. The LS11 or AF Köln is a prototype two-seater class sailplane currently in development at Akaflieg Köln the academic flying group of the University of Cologne. The LS11 first flew on 5 November 2005. Design and development. Akaflieg Köln initiated in 2000 the concept design for the AF Köln. One of the design goals was to use as many standard LS components as possible in order to lower the development costs. This and the large contribution of Wolf Lemke, who performed the aerodynamic and structural calculations, led to Roland and Schneider bestowing the type designation LS11 upon the Akafliegers project. The goal of the project is to design and build a thoroughly capable school glider with top performance for cross-country training, record flying, and competition. The LS11 gets its performance from an extended Roland and Schneider LS6 wing. After the Akaflieg Darmstadt D-41 demonstrated the feasibility of a high-performance, multiplace glider based on the LS6 wing, the Köln Akafliegers felt they could profit from and improve upon that design. The wing structure was redesigned and resembles somewhat the Roland and Schneider LS9 structure. The wings, almost entirely made of carbon fiber reinforced plastic, were manufactured at the Roland and Schneider factory in Egelspach in mid 2001, while the span extensions were built in the molds developed by the Darmstadt group for the D-41. The LS11 prototype was featured as a work in progress at the 2003 and 2005 Aero Friedrichshafen exhibitions in Germany. The maiden flight was to be followed by a comprehensive flight test program in 2006 to be carried out at Akaflieg Köln's home airfield, Dahlemer-Binz, in the Eifel region in Germany. The LS11 is slated for production by the Slovenian aircraft manufacturer Amos Flight. General description. The LS11 is expected to have up to 4 interchangeable sets of wingtips for spans between 18 and 21 meters. The prototype currently has a 20-meter span in keeping with the new two-seater competition class. Water ballast bags inside the wings enable loadings up to 50 kg/m2. 2 ballast tanks integrated into the rudder fin will keep the center of gravity within its optimum range, compensating for ballast changes in heavier pilots. The empty weight was a serious design concern for reasons beyond mere ease of ground handling, as the scope for increasing the wing area was limited. Since it originated on a single-seat design, the Akafliegers strove to achieve an empty mass as low as possible in order to keep the wing loading of the shorter 18-meter span within reasonable limits. Some parts of the fuselage were adapted from existing production types, such as the tail boom of the LS4 and the empennage of the LS8. Considerable redesign was required, however. The span of the horizontal stabilizer was increased. The vertical stabilizer was made both taller and longer to provide the required steering power while keeping the top of the vertical fin at a height comfortable for the assembly of the horizontal empennage. The cockpit, manufactured from carbon and aramid reinforced plastic, was designed to accommodate pilots up to 2 meters tall. Available space is sumptuous for both pilots, exceeding that of all comparable production gliders. The front seat is similar to the LS4 cockpit, and both seats have enough leg and elbow room to preclude the mutual interference too often encountered in tandem sailplanes. The maximum cockpit load is 230 kg. The large canopy is a single unit which integrates the instrument panels into the canopy frame. It is hinged at the back in the Pienkowski fashion and opens with an upward and rearward movement. The practicality of this concept for large glider canopies has already been tested by Akaflieg Köln through the modification of 3 Shaibes F-34 gliders. The hinge is a carbon-reinforced element able to withstand wind speeds up to 75 km/h when open, and was designed to sever the tubing and wiring looms from the instrument panels upon emergency release in flight. The airplane stands on a sprung, retractable main undercarriage with a 6-inch hub and a nose wheel which is likewise sprung and retracts simultaneously with the main wheel. A fixed tail wheel is also provided. This undercarriage scheme simplifies ground handling, since fuselage dollies are not required. The main wheel is located near the glider's empty center of gravity. All controls connect automatically upon assembly in the habitual LS way. The control system is built mostly from standard LS parts. The wings are connected by two main pins inserted into the tongue and fork spar ends, as in the LS6 and subsequent LS types. A low landing speed is essential for a trainer. Wolf Lemke and Siegfried Piątkowski decided to depart from the typical LS system in which ailerons and flaps act as flaperons, using a mixed schedule as featured in the Schleicher ASW27. In landing configuration, the flaps assume a deflection of about 75 degrees while the ailerons remain in a neutral position, enabling slower landing speeds with good control response. Multiblade air brakes extend from the upper surfaces of the wings to give ample glide path modulation. Specifications with 18-meter span. General characteristics. Crew 1 pilot. Capacity 1 passenger water ballast. Wingspan 18.0 m 59 ft1. In 1 in 1 in 1 in 1 in on in wing area 13.4 into 144 sqft. Aspect ratio 24.2, 2.2, 2.2, 2.2, 2.2. Empty weight 360 kg 790 lb. Gross weight 670 kg 1470 lb. Performance. Maximum glide ratio 46 at 100 km/h 62 mph. Rate of sink 0.63 m/s 124 ft/min. Images